us. I've never seen a gorilla with glasses, a chameleon with contacts, or a moose with a monocle, although I did see a spectacled bear once. But like 7 out of 10 Americans, my eyes don't bend light correctly, so I've worn glasses since 5th grade. It's a confusing question. How did our species survive the trials of natural selection if so many of us can't see? We can't take otters or ostriches to the ophthalmologist, so it's hard to know exactly how common bad eyesight is in the animal kingdom. But if you can smell, hear, or feel your way through life, good eyes are expendable. Many species that rely on seeing sacrifice clear vision all over to see extra sharp where natural selection demands. For most visual species, you're more likely to become a meal before you pass on your blurry genes, so they vanish from the population. But modern humans live a pretty comfortable life, so natural selection has let us slip through with bad eyesight. The lens inside your eye isn't rigid, more like really firm jello. It's made from flexible proteins called crystalline. They let visible wavelengths pass through, but the lens's rounded shape bends the light. Refraction, just like what happens where air meets water. We can't focus by moving our lens closer or farther from the retina the way a camera would. We actually squish and pull our lens to change how it bends light. The objects reflect light in all directions. The farther away an object is, the angles between the light rays entering our eyes are smaller, and our lens doesn't need to bend them as much, so tiny muscles relax and flatten it. As an object moves closer, light rays are hitting our lens at wider angles, so muscles squeeze the lens into a rounder shape to bring the focal point right onto the retina. We do all this involuntarily. Healthy eyes can focus from infinity to here in less than half a second. But in many of us, this process doesn't work perfectly. People with myopia or nearsightedness have trouble focusing on objects far away, often because the eye is too long, kind of football-shaped. The lens focuses the image in front of the retina. Or if you have astigmatism like me, your cornea is too round, producing weird blurry effects. This is corrected by using a lens that spreads the light out just a tiny bit before it enters the eye. The focal point now hits right on the retina. If the eye is too short or the lens can't quite squish into a round enough shape, the focal point moves behind the retina when trying to view things up close. We call this hyperopia or farsightedness, and it's corrected using a lens that slightly focuses the light in front of your eye, kind of like wearing tiny magnifying glasses. As we age, people often get presbyopia. Our lens becomes less elastic, unable to squish enough to bring the closest objects into focus. If somebody already requires distance correction, often they'll be fitted with bifocals or contacts with 2 different types of lenses, one for far and one for near. Contact lenses correct these problems the same way as glasses do. You just don't notice the different lens shapes on the tip of your finger. Corrective surgeries like LASIK don't actually work on your lens. They use lasers to reshape the round cornea in front of it, adjusting how it naturally bends light. Strangely, over the past half-century, eyesight is getting worse in developed countries. 60 years ago, nearsightedness affected 1 in 10 Chinese people, but today it affects 90% of the younger generation. In Seoul, Korea alone, 97% of 19-year-old males need corrective lenses. The change is too fast to be due to just genetics. It was originally thought that the culprit was too much time spent reading or staring at devices up close, but newer research suggests that the biggest risk factor could be kids spending less time outside under bright sunlight. So, how good can our vision get? Could we see like eagles? Well, when our lenses, natural or prosthetic, are just right, the limit of human vision is lower than 20/20, actually closer to 28. Professional athletes in visual reflex sports like baseball are often down in this range. The limit to our vision doesn't come from being able to bring things into focus. It's because the cone cells on our retina are only packed so close together. Like pixels on a camera sensor, we can't pick up detail smaller than a single cell. Birds of prey like hawks have more tightly packed cells on their retinas, so they can see more detail than we can. What's strange is people who have had their natural lenses removed can see expanded wavelengths down into the ultraviolet range. Claude Monet, the artist, was one of these people. We made a video about him. You should check it out. We might not ever see like Superman, but thanks to physics, we can bring our vision into focus. stay curious. Thanks to the Great Courses Plus for sponsoring this episode. The Great Courses